Yeah, so good evening, students. So, students, we have just started the revision part of this particular chapter, light. Okay, so we have finished one revision session. Okay, students. So this particular chapter is for 10 marks. So today also we'll be completing only the basics. Okay, so I'll try to close the basics. Next session we'll be going for the mirror lenses. Okay, where the 7 mark question. So up to today's session it is only for 3 marks, students. Okay, basically 1 mark MCQ, 2 marks, or maximum you can expect 3 marks. Nothing more than that you can expect, student. Okay, yeah, but topic wise also I'll try to give the marks how that particular marks are to be distributed. Okay, so students, so what did we learn yesterday? Quick recap. So we have started with reflection. In the reflection, what did we learn? We learned loss of reflection. What was the loss of reflection? So it's incident ray, reflected ray, angle equal to angular is the first law. Incident ray, reflected ray, normal. They all lie in the same plane. Okay, two laws. Then we went to the then what was the maximum mistake students do? There's a little geometry involved there. Though there you be very cautious, student, in finding the answers. Okay, where something like sometimes he will give to the plane mirror, sometimes he will give to the normal. So that way you need. Okay. Then we went to the refraction of light. Refraction. What is refraction? It's just the bending of light. Just the bending of light. Just the bending of light is refraction of light, student. Okay. So in the refraction again, we have learned about two scenarios. So the light we can come from water to air, denser to rarer, away. You see, it should have gone like this, but it is moving away from the normal. This here is the normal. Dara. Another scenario, rarer to denser, RDT towards the normal. It should have gone like this, but it is moving towards the normal. Okay, so those two are, and I asked you to remember two scenarios: this particular activity and this activity. Remaining all questions, you just compare with these two activities, and you can give all the answers. Okay. Then we went to here. You see, all our eyes are getting cheated, right? Apparent depth is less, apparent depth is more. How much our eyes are cheated? How much our brain is cheated? That is how you need to find some technical term. Refractive index. How is it derived, student? If at all light is coming from the vacuum, you all know light travels with a speed of 3 into 10 power 8 meter per second, which is nothing but c. Okay, should not forget in vacuum there are no atoms, no particles, no dust particles. So it will directly move with the same speed. But when the light enters the glass, definitely here two things are happening. First thing, bending. Second thing, speed is reduced. Speed is reduced. Two things are happening. Now, how is this particular refractive index is counted? Mu equal to, if a light is traveling in vacuum, the speed is c. If a light is traveling in this glass, V of g or only V, this is nothing but the refractive index of the medium. This is how we have calculated. Okay, student? But technically speaking, just by looking, how can you say who is denser? 2.5, you can assume it is a football ground with more people, football ground with little people. More people, more bending, less speed. Less people, less bending, and little reduction of speed compared to vacuum. Okay. So here you see mu and V are related to inversely proportional. Okay. Yeah, this is what we have learned yesterday, and we have done many questions yesterday. Okay, so now we are continuing with some of the questions. The first question on the screen. Read the question. I think one student gave the right answer already yesterday. I'll take the help of her. Come on, student, read the question. The refractive index of four substances. There is a medium, two mediums. Why the light is traveling air and medium? So this is air, whose mu is generally we are considering 1. This is a substance. Substance can be anything. PQRS. Okay. Now what I should draw? I should always draw the normal whenever the light is intersecting at two different mediums. Okay. First scenario I'm taking P. P. So when a ray of light is passing like this, so definitely mu equal to 1 and P value is 1.77. Okay, so let me see the answers. Narendran, right answer. Megha, right answer. Rujuta, right answer. Harshini, very good, right answer. Yes, Rujuta, how did you do, student? What is he asking?
They're asking in which of the substances will the refraction angle of refraction be the highest?
Okay.
So I chose option D because the refractive index is less. So
Oh,
which
great.
means the speed of light is traveling faster in it.
Mm. No, why
And
speed of light? Bending. Bending you speak. Speed of light doesn't matter here. Bending. Because I want angle of refraction, right? I only speak about bending. You are right, absolutely right. Speed of light also reduces. Same about the bending. If at all 1.31 is there, what happens to the bending?
the bending of light is maximum, right?
Mm.
Like it's from air to the substance, it moves away from the normal.
Away from the normal. Yes, you can. So the bending is less, not maximum. Bending is less. Okay. Yes,
But
Narendra.
it's moving away from the normal, right? So it should be bending is maximum.
No, no, no. Bending is original path is this. This is what the original path going. Okay. Now you are saying, sir, let me take P. So let me take P only, sir. 1.77. You see mu 1, mu 1.77. What is the criteria, sir? Rarer to denser. So it should move towards the normal. So in spite of moving like this, it will move towards the normal. Why, sir? But normal is here towards the normal. Now you see, student, is bending maximum or mean what is bending? Is this bending or this one bending better? Top one or down one? What is bending?
So the top one,
No, no.
the like the normal that you do.
So you see, here there are two things. Okay, so bending is this better green. Okay, so you should not. So he's not asking bending. He's asking angle of refraction. Okay,
Okay.
okay. Bending means originally she's going like this. Now it has slightly bended like this. This much only bended. Okay. Yeah, so Narendra, yeah, I know that you know it, student. Very good to see. Harshini, bending leads towards the bend leads towards the north. Yes, right answer, Harshini. Bend leads towards the north. Okay, so student, the red color light should have gone like this, but rarer to denser towards the north, it is bending. Okay, but you take the scenario of next Q 1.50. So here also you should say, sir, 1 to 1.50. Black color also is going at the same angle. He said it is traveling at the equal angle. So in spite of red, I am taking black now. So here also black 1 to 1.50, rarer to denser. It should bend. It should bend, student. But as it is less than 1.77, it will bend a little. See, bending little I am taking. Initially it was 1.77, more bend. If there are more people in 1.77, more people, it will bend more. Okay? 1.50, less people, it will bend less. Okay? Let me take the scenario of 2.42, not the red, I'll take the green color. 2.42 R. R is 2.42. 2.42 is diamond, I guess. Okay? Yeah, in the same place when green color light is coming, yes, sir, mu equal to 1, 2.42 rarer to denser towards normal, but you see 2.42 fully crowded. It should bend more. So where is bending? To the original path, I am saying the bending. My original path is there, but it has bended. But where should it bend? Towards the normal. Okay. Last scenario, let me take this 1.31. Yes. So in spite of green, I am using the blue color now. Sir, mu equal to 1 and s equal to 1.31. Definitely it should bend. But you see 1.31 is less crowded than all of them. So it will also bend. It will bend a little only. Now what is he asking? He's asking angle of refraction. What is angle of refraction? This is angle of refraction. 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 Whose angle of refraction is more? The blue color, which is nothing but yes, substances. Okay, so Rujita understood better. This is what you thought. Are you felt the
Yes,
same
sir.
thing? Yeah, yeah. So I
Yeah.
think that's a little communication gap. You said it absolutely right. Okay. So the bending, if whenever I am asking bending, you should say, sir, original path is this, bending is this. Only little bending, little only bending. But he is asking the angle of refraction. So this you should consider from here. Okay. So obviously, yes is the right answer. Okay. Next question. So please see the arrow. So he will not give this. Again, I am repeating. A lay or light enters from medium A to B. He will not give this statement, student. You should see where is the arrows written. and your paper is not of good quality sometimes. The arrows may be misguiding. Take the help of invigilator. You can see the light is moving from medium A to medium B. Tanish, very good. Narendran, good. Mega, good. Mega, yesterday you did not join, right?
No, sir.
Okay. Rujita, very good. Arshini, nice. Okay. So Tanushri, how will you do, student? He is speaking about the refractive index mu B relative to means divided by A. This one is asking. So how will you do this? So now you say me whether which medium is denser, which medium is rarer, according to you. Rarer means less people, denser means more people.
A medium is rarer and medium is denser.
Very good, right answer. Okay. So student, if you are able to see that way, that's right. If you are not able to see that way, please draw. Sir, medium A to medium B, light should have gone like this. But now you see light is bending towards the normal. That means rarer to denser only towards the normal. So rarer to denser. That means this is rarer, this is denser. So obviously, student, mu of B is greater than mu of A. Just know what she said. Rarer to denser. But he did not ask mu of A, mu of B. He asked mu of B into mu of A. So when such types are there, please take the help of maths. Sir, mu of A is there. Can I write mu of A into 1? Yes, you can write. Now bring mu of A here. Mu of B by mu of A is greater than 1, greater than unity. Okay. So in exam, please take the help of the graph like this. Okay. It will be little bit confusing questions are there on this topic. 1 mark only you'll get. The index of refraction of index mu of D 2.0, speed of light in diamond V of D is asking. Formula connecting both of them is mu of D equal to C by V of D. No, Rujuta. How can a diamond have a speed this better? Always the speed of a light is maximum is 3 to 10 power 8, which is in vacuum or sometimes air. All the speeds will be less than that. Yes, Harshini, right answer. Narendran, right answer. The formula is here, and you know C is nothing but the vacuum speed. Yes, right answer, Rujita. Mu of D to C, velocity of light in vacuum, fixed. It will not change. V of T. Mega, right answer. No, Tanushree. Yeah, you see, that's what I said. Light is maximum in vacuum beta. So in the world or in this universe, there can't be more than this number. Light can only travel maximum in vacuum because there is nobody to stop it. Okay. So this answer can't be at all. So it's just mathematical help you take, you'll get the right answer. Okay, Tanish, right answer. 1.5 to 10 power. Understood, Tanushri? Should I repeat it?
Can you repeat it?
Yeah, you know this formula mu equal to C by V. Okay. Mu is given to C, which is speed in the vacuum 3 into 10 power 8. V you need to find. So V will go there, 2 will come here. 3 by 2 is 1.5. Or else in the exam also you can never give these two. If at all you don't have time, you are going for the just attempting the answers. So you should not select these two. Logical guess will not give these two answers. Why? Because speed is maximum in vacuum. So in diamond, definitely speed should be less. Okay, 3 into 10 per 8, not possible. 6 into 10 per 8, not possible. The answer might be here or here. So that's a logical guess you need to do from these two. Okay. So student, you don't have negative marking. So please don't leave MCQs at all in your exam. Okay. In the last 1 minute also, you can give all the 10 MCQs or 12 MCQs answer. 1D, 2A, 3C, like that, at least you do it, student. If you are attempting from section E, if you have started your exam from section E, if you are not finding time for section A, the last one, last 5 minutes, so please guess it. Don't leave it unattempted. You might get 3 or 4 correct if your guess is right. And if you have some time for logical guess, do the guessing in the right way. You see, I can guess only from these two.
देखो पापा ये भी बोल रहा है, मामा ये सर भी बोल रहा है, देखो क्या बोल रहा है।
Speed of light in glass is 2 into 10 power 8. Find the refractive index of glass. हाँ उदाहरण सही सुन रहा, लास्ट से पहले तक आना चाहिए। सेक्शन ई, सेक्शन डी, सेक्शन सी।
व्हाट सर?
सही बोल रहा, पापा मामा को सुनाओ बोल रहा हूँ मैं।
पापा मम्मा को क्यों सुनाओ सर?
अभी तुमने बोला है पापा सर भी बोल रहा है बोल के, वही सुनाने के लिए बोल रहा हूँ। ओके।
I was an unwell. See sir, I'm doing so much तारीफ sir.
Thank you, thank you. That's why I'm not just arguing with you. Thank you, I said. So please let your mother and father listen it.
I was telling them to like tell about you to my cousins who are going to go in 10th next year.
Acha. Thank you, student.
You're
That's
welcome,
that's
sir.
a great favor from the students. That's Guru Dakshina. But Mega is not at all suggesting anyone. No, no, no. His tuition is Bekar tuition. He has not finished biology exam, biology syllabus at all.
Sir, no one else is willing to change from the current tuition. Everyone, sir, is also telling them no, stay here, suggest. So everyone's having problem.
Sir,
Yes.
politics we have to play, sir. It's very smart, sir. This tuition business very smartly you have to do, sir. Politics, sir. Sir, hire me, sir. Managing director, veteran institution, sir. I'll show you, sir. Full
I
Hyderabad.
want to continue my tuition for next 10 years, so I don't want to take risk.
No, sir. Full Hyderabad I'll get, sir. Managing director, sir.
Okay. You carry on your studies for next 6-7 years. Afterwards, definitely, I will hire you, or you may hire me as a faculty if you are at very good position. Yes, Rujita, right answer. Harshini, right answer. Megha, and the speed of light in glass. So, students, this is an easy, right? V is given. Mu is asking. What is the formula connecting mu and V? Mu equal to C by V. Okay. So, mu equal to C is fixed. 3 into 10 power 8. V is 2 into 10 power 8. This gets cancelled. 3 by 2 is the right answer. Okay. So, students, here is what you're comfortable. Okay. So, this we have read only two formulas. Angular equal to angular. Angle of incidence, angle of friction, mu equal to C by 2 formulas. We have done many questions, okay? Not required. Yes, in refraction, bending of light occurs due to, like in a football ground, you increase your speed sometimes, you are decreasing your speed sometimes, or you're walking straight, you're bending sometimes. Why is that happening in the football ground? Because sometimes it is overcrowded, sometimes it is vacant. So that means different densities are there in every medium. The right answer, Harshini, Narendran, Megha, Tanesh, Tanushri. Good. Yes, students. Consider these indices of refraction. Glass is given, air is given, water is given. Based on the refractive index of three materials, arrange the speed of a decreasing order. Please remember it's a decreasing order. Basically, it's a mathematical question. The decreasing order is what you need to check. So, then you did not get any pre-board answer mark, student, till now?
Sir, we won't get, sir, now.
Why?
Sir, we'll get online maybe 1 week before board, sir, now.
What is this?
They
No,
won't
Ruchita.
correct, sir, now.
You won't correct now. So you are writing, you are working hard, you should write. No, Tanushri, little wrong. So obviously, you will correct yourself if you get the result, right? You see, I generally try to give the result by next weekend, generally by Sundays, because other days I don't find so much time to check the papers. because it's online papers you submit, so it's very tough to check the theory part, subjective part. Tanish, no, all are giving answers. So Narendran is right, Harshini is right, Megha is also wrong. Only 2 students right. Please check the answer again. So mu of glass, mu of air, mu of water is given based on the refractive index. Arrange the speed of light. You know the relation between speed of light and refractive index. Whose mu is more, refractive speed is less. So whose mu is more, glass is more. So V of glass is less. Whose mu is less, air is less. So V of air will be more. Refractive index and V are less. Now I need to arrange in decreasing order. Decreasing order means V of air should be more and V of glass should be less. V of water. What is so tough in here? You all given wrong answer. C is the right answer.
Sir, I accidentally gave an ascending. Well, no,
Pardon?
not ascending, increasing orders of decreasing. I
Good
accidentally
evening, sir.
Oh, yeah, good evening. Okay. Okay, so please see, you already know the answer, still you gave the wrong answer, only the maths help. Please take the maths help. Okay, so Tanushree, understood beta?
Yes, sir.
Other you're not at all giving the answer. I'm tired of saying to your parents also. I don't read the question completely, Acha. I did not consider only the indices. Okay, so that's the reason, student. Okay, so read it properly or ask me sometime. So you see, you are giving it in the faster way. That's the reason I'm explaining answer. If you take some time, I am able to calculate. Okay, so students are taking some time. Even I'll explain the answer somewhat by giving some time. Okay, so student, we have done up to here. Okay, refractive indexes, we have learned the meaning of refraction. We have used this particular formula. Okay, now let us see laws of refraction also. Okay, here also we have 2 laws. The first law is again the same thing, whatever we have learned in law of reflection. Incident ray, refracted ray here. In the reflection, we have learned about reflected ray. Here, refracted ray and normal, all at the point of incidence lie in the same plane. Okay, so there is no much thing to explain here, which I have already explained in 3-dimensional viewing, law of reflection. Okay, but you see, student, here there is no question framed at this point except the MCQ part. But when you go to your class 11th and 12th, when you learn in the particular maths, this 3-dimensional figure, ZZ axis, ZY axis, ZYZ plane, like that, when you learn, many questions will be there from laws of reflection of this law. Because there he will try to assume. So the particular light is traveling in YZ plane. When the XY plane normal will come, what will be the refracted ray? Like that he will frame. Okay, but that's good here. So we don't have so much idea about the plane. So you restrict yourself only for the MCQ part. Okay. Yeah. Now let's go to the second law, which is very, very important. Okay. Second law, which is very, very important. What is the second law? Let me write the second law mathematical, then I'll explain. The ratio sine of angle of incidence to the sine of angle of refraction. You see, this is the point of incidence. Sine of angle of incidence means I. 2 means divided by sine of angle of refraction. Angle of refraction is R. This is equal to constant, he said. Okay, so please write these 2 points only in your, if at all the question is asked for loss of refraction for 2 marks. Please write only this much. Try to remember like this. Sine of angle of incidence to sine of angle of refraction. This is smaller, refraction is constant. But you see, when you want to go to numericals, this information is not at all enough. Okay, this information is not enough. Why? Because now the question comes are equal to constant. What is that constant? Then I'll say mu is the constant. Then again question comes. Sir, we have 2 mu's here. You see, this is air, this has 1 mu. This is another mu and this has 1 mu. So what is this mu? Is it mu1 by mu2? Mu2 by mu1? That question comes. Okay. For that reason, student, to know what is this, you need to know what is Snell's law, from where the second law is derived. Okay. And all your numericals will be solved only by Snell's law, not by this law at all. Okay. So please let us learn Snell's law. Okay. For 2 marks, a theory part, this is more than enough. But for numericals, you need to learn where this formula has been derived from. Okay. Second medium to the first. Yes, you're absolutely right. So let me explain that as per Snell's law. Okay. So student, first of all, I need to apply Snell's law at the junction, at the point of incidence. Okay. Let me apply Snell's law. What is the Snell's law saying? What does the Snell's law say? If at all the light is coming from this medium to this medium, I am assuming this is mu1, this is mu2. What the Snell's law says is equal to mu1 into refractive index into sine of angle of incidence, sine of I, equal to, now I have finished the upper medium, now below medium. What is the refractive index? Mu2, sine of angle of refraction R. Okay, please remember Snell's law like this. Product of refractive index into sine of angle equal to product of refractive index into sine of angle. Okay, at the point of incidence, Snell's law. Okay, now you can see. Okay, sir, now as per this fellow said sin I by sin R, right? So I'll bring sin I over here divided by sin R over here. So obviously it will be mu2 by mu1. Okay. So, but what is mu2 by mu1? Mu2, if at all you are taking diamond, 2.42 is fixed. If you take mu1 air, 1 is fixed. 2.42 by 1 is always a constant. You can't change mu2 and mu1 value for one particular medium. So that's the reason sin I by sin R equal to constant. Understood, student? So this is what he has given, but this meaning is this. This came from this Snell's law. Mu1 sin I equal to mu2 sin R. So Harshini, following student?
Yes, sir.
Oh, second medium to first medium, right answer. Okay, Tanushri, understood beta Snell's law?
Yes.
Okay, yeah. So student, let us do some numericals on Snell's law. Okay, yeah, I'll take one more example. You see? Okay, so 1 second. Let me stop screen and erase something on here. Erase something. So I have given some extra information. Yes. Okay, so now suppose there is a case-based question which is very, very rare. Case-based question doesn't come. Only 1 mark and 2 mark question you can expect from this particular topic. Okay. Suppose now if I want to apply Snell's law now if it is given picture like this, he is asking me to apply Snell's law at two different places. So obviously Snell's law is applied at the junction of the two medium. You see air, water, glass. Suppose you have just holded a glass of water. Light is coming from air to water, from water to the glass thickness. So that is what the scenario. From air to water in your glass, from water to the glass thickness. Okay, so light is traveling like this. Now, so let me apply the Snell's law at this junction. Air, water. So what is the Snell's law? I'll write the equal symbol. So first this medium, mu of air into sine of angle of incidence. What is sine of angle of incidence? Normal and incident ray 60 equal to, where is the light ray going? Water. What is mu of water? Mu of water only I'll take, I don't know, into sine of angle of refraction. What is the refracted ray? 45. This is what you need to apply and keep the Snell's law. Okay. Yes, Harshini. Please say me the Snell's law over here, beta. Snell's law over here, water, glass, medium, two different mediums. Snell's law can be applied. Snell's law is applied whenever we are speaking about mu and angles. We don't have form. This is the third formula from yesterday. First is angle I equal to angle R. Only angles we spoke. Next mu equal to C by V. Different speeds and refractive index. Snell's law is when we spoke about refractive index and angles. Then Snell's law. Yeah, Harshini, same student. Apply Snell's law over here. Harshini, are you there?
Yes, sir. It wasn't unmuting.
Okay. Apply beta. Where is the light coming from? At this junction? I think
So
she
where,
has-
sir? Yes,
Where is
sir. The
light?
voice is working. Yes, sir.
Where is the light coming from at this junction? Which
So
medium?
from medium to
Medium 2, which is water. Say me, what should I write Snell's law here? Mu
of medium to
or water, yeah, into Okay,
The
sir.
sine 45.
Very good. Sine 45. Why, beta? Here is 45. But
Sir,
I
it
want
is equal to this angle over here, the
very
other
good,
angle
very
also.
good. Okay, so student, here angle of incidence is not given, but she's saying 45. Let me write that first. Now again you say Harshini,
Glass.
mu of glass into sine of. So say me the rough value.
What rough values, sir?
Oh,
30 maybe.
very good. Absolutely right answer. Okay, so student, when she applied here Snell's law, sir, light is coming from water to glass. Mu of water into sine of angle of incidence. Student, here it is not given. But please use your geometry. Sir, this is a normal, this is a normal, both are parallel lines, and this is a transversal. This is a transversal. That means this angle will be same. This will also be 45. Alternate interior angles. That's the reason angle of incidence is 45. I have taken 40. Okay. Next thing, you see, so he will give here. I did not mention it here. Okay. So now you should not take this as 45, sir. This is 45. This will be 45. Vertical opposite angle. No, your light ray has bended now. If at all this total angle is asked, then it is 45. Total angle. So this is 45. This angle will be 45. But you have two different lines here. This is not one line. But you know, sir, water to glass, rarer to denser, towards normal means it has moved more towards normal. If it is 45, it should be less than 45. That's the reason she has taken sine 30. Okay. But he will generally give this angle at 30 degrees. Okay. Understood, Megha? Megha, are you there? She is not at all there. Karthik, are you following Snell's law?
Sir?
Are you following Snell's law?
Yes, sir.
Okay. Okay, students. So with that Snell's law, let us do some numericals on the Snell's law. Okay. You see, when I started earlier in the very regular session, you all were not aware of signs. Okay, sir, what is this sign? So I have explained the whole trigonometry again at that particular scenario. But anyhow, now you all are pro of trigonometry values. Okay. Please remember sine values, tan values, cos values. They are very, very important. Okay. Yes. First question. Narendran, Tanish, Avdan, Karthik, Harshini, please switch on your cameras.
Sir, your voice is breaking. I'll rejoin.
Okay, okay.
Sir, I'm having network issues.
Rujita, take some time and read, check your answer. Yes, Narendran, right answer. Karthik, right answer. You see, yourself, you are giving right answer when you are checking second time. So make it that is. So first of all, you assume some answer. Again, you check and then ping the answer, student. This is the way you can correct yourself. First law of refraction, we have just seen incident ray, refracted ray, and normal are perpendicular to each other. This is absolutely right, but that is not first law. But perpendicular also not required. Normal, no, that's wrong statement. Tanushri, right answer. Incident ray, reflected ray, and normal all lie in the same plane. This is right answer. This is wrong. Wrong. Plane fly in the sky is absolutely right, but that's not the first. Okay, so C is the answer, students. C is the answer. Right, what is the formula for Snell's law? Take some time, and just now you have learned Snell's law. So what you know, you write first, then you check which parameter he is taking. You see, he has not taken mu2, mu1. He has taken n2, n1. That you can just correlate. He has not taken I and R. He has taken theta 1, theta 2. That you can correlate. First, write what is Snell's law according to you. Then check what is the right answer. Tanish, right answer. Thank you, Avdan. Right answer. Tanushri, very good student. Right answer. Rujuta, super. Narendran, very good. Okay. Snell's law. Okay. So what I know Snell's law is, sir, mu1 sin I equal to mu2 sin R. Only this much I know, student. but he has given some n2 n1. So let me take n1 sine. He has taken theta 2 theta 1 n2 sine theta 2. Now he has taken sine theta 1 by sine theta 2. Obviously n2 by n1. Right answer. Okay, Harshini, right? No, Harshini. Mega? Yes. Okay, so he will confuse you like this, student. It is mu1 theta 1. N1 theta 2, not theta 2. N1 theta 1 it is. Okay. A light passes from medium X to medium Y. Suppose there are medium X and medium Y. Obviously, I need to draw the normal, right? What is saying? If a light ray is passing from medium X to medium Y, no refraction of light occurs, student. What does that mean? There should be no bending. No bending should happen.
Sir, I have one doubt.
Yes.
If it says that like a ray of light hits a glass slab obliquely, it means 45 degrees, right?
A ray of light passes to medium X to medium, no refraction of light. What
No,
is the
no,
question?
not this question, not this
Okay,
question.
okay.
If it says a ray of light hits a glass slab obliquely, does it mean 45 degree? Or it can be
So,
anything?
can be anything, right? Obliquely means can be anything. Okay,
Because we
so
had that in our exam today, and many people mistook it for parallel and they wrote parallel instead. Not
Hmm.
parallel, sorry, perpendicular. So they drew a straight line and said that there's no change.
Narendran right answer, Mega right answer, Tanushri no student, Tanish right answer, Rujuta right answer. Yes, Narendran, help me student. How did you do? No refraction of light means refraction itself is bending. So he's saying no bending of light is possible. Okay, okay, no problem. Now it's fine. Okay, yes. Narendran, same student. How did you give this answer? So you have given D as an answer, right? So your answer is right. Okay, so students who gave D as an answer is right. But why it is right, I want. Yes, Narendran, can you explain? No, Mega, please explain, beta.
So then that means that like the ray and the normal are both the same.
So why?
So it forms 0 degree, right? They're the same line.
So that means if at all I take a ray of light like this, can't it go like this? Angle of incidence is 0. Can't the refracted way here can be something angle?
According to the ground, it's 90 degree. According to the normal, it's 0.
That is fine. You are only giving the answer to this. But his question is ray of light passes from medium X to medium. Refraction of light, no refraction of light. So you
No
want to say,
refraction means it has to be perpendicular. It can't be any other angle.
theoretically you are right, but how can you explain it mathematically or with formula? That is what I'm asking. So you see, student, so this is what the question. Now the question is, what should be this angle so that it will not be bending? That is what the question. So what many students gave as the right answer is, so students are giving like this. So sir, I'll send a ray of light like this. Then all the refracted way will go like this. There will be no bending at all, they are saying. Okay. There's no change in the direction. Yeah, so you all are giving the theoretical answer which you remember. But how to prove it? No refraction occurred. Yes, no refraction occurred. That is fine. But why is that? When I'm making, you see, the red color is nothing but the normal, and the black color is nothing but the incident ray. So angle of incidence is 0 here. I can clearly see angle of incidence is 0, and angle of refraction is also 0. Refraction. This is not reflection. Refraction is 0. So bending is not happening fine. But why is it so? Okay, so student, whenever he is asking refractive indexes and angle, so again you take Snell's law. Apply Snell's law over here. If I apply Snell's law, so mu1, mu x, this is x medium, sine I I'll take, equal to mu y into sine r. Okay. Now, what should be this angle of incidence to make this so that these two values can be equal? When can that be equal, student? You take some angle, you take sine I equal to 90. That means the light ray you are taking like this. So mu x sine 90 equal to mu y sine r. R I don't know. So mu x equal to mu y sine r. So student, here we can't predict. Sir, mu x, mu y both are different, but what is sine r we can't predict at all. So that scenario is very tough. Okay. So what students are saying that, sir, you make angle of incidence 0. So exactly this case, black one case. Okay. Now you see left side what is happening. Sine 0 is 0. Mu x can't be 0, but mu x into 0 is 0. But what about right side? So right side also it should be 0 as per Snell's law. When can be right side be 0? If mu y is 0, 0 into sin r is 0. But mu y can be 0. Is that possible? Mu y cannot be less than 1. The minimum value of refractive index is 1. So what can be 0? Sir, sin r should be 0. Then only it is possible. Okay. So Snell's law here is helping you to decode what should be angle of incidence, what should be angle of refraction. And this is only possible when I and r are 0 as per Snell's law. But for remaining all the values, it is very, very tough to manage that particular ratio equal. That particular left hand side, right hand side 0. That's the reason this is right answer, student. So theoretically this way, mathematically this way. Okay, I'll show you one video. Look at the here, the very first scenario. You see here, this is light. Light is going to the this protractor. So rarer to denser. What is angle of incidence? 90 degrees. You see, this is surface normal 90 degrees. What is happening to the refracted ray? It is exactly going in straight manner. Again, you observe it here. The light is coming exactly 90 degrees to the to the normal. Again, the refracted ray is going straight. Okay, so there is no bending at all. All are moving in straight line. So this particular scenario exists only when angle is 0 degrees. Angle of incidence is 0 degrees. Harshini, understood beta Harshini?
Sir, but
Yes, sir.
90 degrees perpendicular then.
Surface. No, 90 degrees to surface. But what is normal here? Normal is again, we need to draw 90 degrees to the, this is surface. 90 degrees is again this normal only, right? Normal and light angle of incidence, both are 0 degrees. I can't draw like this. Okay, this is surface. To the surface, I need to draw normal means I need to draw this line. Again, the light is also going in that line. What is the angle of incidence? 0.
Okay, sir. Yeah.
So student, I am intentionally taking this part many questions because you see in your book also there are no more questions. In the, I don't know if you're trying from reference book, I don't know. You'll get many questions from reference book from this topic. Okay. As NCERT has not given many questions, I am taking more time for these questions. I am still at the basics only. I am still only for searching for 3 marks only. From next session, we'll go for 7 marks. And please expect a session on the Sunday, where I'll be taking plane mirror, concave mirror, convex mirror, concave lens, convex lens. Only students who are not comfortable join. It's optional. And students who are listening to me for the first time, please join. Okay, so if you are comfortable already with this topic, please utilize your time. But again, sample paper you should be there with me. Huh? Sample paper you should be there with me. Ruchita, right answer. Karthik, very good. So Karthik, I'm able to see very good answers from you from last 2 days. Tanish, mathematical issues. Please draw the rough diagram that will help you calculate the refractive index of material incidence. Angles and refractive index is speaking. Snell's law you should apply again. Mu and theta. Please be available for the sample papers. They are must student.
Sir, could
Student
you
who,
check my answer?
okay. I'll check. Harshini, right answer. Narendran, I don't think so. Narendran, Mega, right answer, I guess. Refractive index whose angle of incidence is 90 degrees. What does that mean? But angle of incidence 90 degrees means my light rays coming like this. Then only your angle of incidence is 90 degrees. You see, normal line, incident ray 90 degrees. Angle of refraction 45 degrees. That means your ray is going like this. This is 45 degrees. Please apply Snell's law. What is there here? Snell's law apply, student. Tanushri, very good student. Okay, apply Snell's law over here. Tanish. So Snell's laws are mu1 sine 90 equal to mu2 sine 45. What is he asking, student? Refractive index of the material. Whenever this question is asked, material means medium number 2. Medium number 2. This is material. So generally he will taking this as air, this is material. Okay, that means mu2 by mu1 he is asking. Sine 90 by sine 45 equal to mu2 by mu1. So mu2 is asking a refractive index. So I should compare with mu1, mu2 by mu1. So 1 by root 2 equal to mu2 by mu1. So that is root 2. Mu2 by mu1 equal to root 2. Okay, so sometimes we will take n, this value will take n. Okay, Narendran, right answer. Tanish, understood beta? Tanish.
Yes, sir. Yes, sir.
The refractive index of air is one angle refractive index. So let me take the medium and normal. Please draw the rough diagram. Please, I'm requesting you all. That will give the clarity what is asking. The refractive index of air. So this is air. This mu equal to 1 he said. And the incident angle is 60 degrees. That means light rays coming. Incident angle is 60 degrees. He did not mention anything. So please take the reference with normal line. And the refraction angle is 30 degrees. That means the red color would have gone like this, but as it's bent, the bending is at 30 degrees. Oh, that's easy question. Just you need to apply Snell's law. Narendran, I think you're right, student. Ruchita, right. Karthik, very good. Please apply Snell's law here. We speak about refractive indexes and angles, nothing more than that. Mega, right. Snell's law, mu of 1 into sine 60 equal to mu 2 into sine 30. Mu 1 he has given 1, sine 60 is root 3 by 2, mu 2 is asking, sine 30 is 1 by 2. Finish, student. This gets cancelled, mu 2 equal to root 3. This is right answer. Adan,
Sir,
so you know Eid ka Chand, right? You're well aware.
yeah,
So
sir.
you do the same. Only one question in one session, one answer you will give. And I should only be happy with that only one answer for the entire session.
Sir, I'm trying, sir.
If you try, you will get. You're not trying, that's the reason you're not responding. I'm sure about it. Okay, so this is what root 3 student. Narendran, Karthik, Harshini, switch on your cameras. Show up your face, student. Karthik, what's happening? Why are you not switching on your camera, Karthik? Want to go to salon and do some facial before you showing your face? Karthik, please respond, student. Narendran said some answer. Right answer, Narendran. Charging my laptop. I'm on my bed, my God. Harshini, Rudita. Right answer, student. So, student, the question is same, I guess, right? Ray of light traveling through the air at an angle to the 60 degrees. See, this is ray of light, 60 degrees. So, previous question also the same 60 degrees. It passes into the water and halves its vertical angle. What is the vertical angle? 60 degrees. So, now it is taking half, matlab 30 degrees. The same previous question, 60, 30. So in previous question you got 3. Here also you will get 3. Root 3 you got. Here also you will get root 3. But answer is somewhat like this. Root 3 is nothing but 3 power half. A is the right answer. Same question, previous question, 60-30. You see? 60-30. Same 60-30. Yes, Tanish. Okay. So now let me mix the questions. Huh? Yeah. Now let me mix the questions. Reflection and reflection. Okay. Same question. Yeah. Please draw the diagram. You'll get the clarity. If you are hesitating to draw the diagram, you will never get the clarity. At least rough diagram. On a glass plate or a light vessel. So this is a glass plate. So let me draw this particular. A light wave is incident. A light wave is incident at an angle of 60 degrees. At an angle of 60 degrees. If the reflected and refracted waves are mutual perpendicular. Okay, so some answers are already given. I don't know, student, but you have given the answer. That's wonderful. The reflected and refracted waves, 2 waves I'm speaking about. That means there is some reflection, there is some refraction, and they both are mutually perpendicular. What does that mean? They are at an angle of 90 degrees. The refractive index of the material, so this is mu1, this is mu2. He is asking mu2 by mu1. He is asking mu2 by mu1 कितना है? Let me check with others. Harshini gave, yes, right answer. Rudita, Harshini, Narendran, Mega, no student. Oh. So students who are switching your schools, you have another option. I'm opening my own school here. You can join that school. Okay. Class 11. Okay, so student, this is what the question is. Okay, now he is speaking about reflected and refracted wave. So now please remember the laws. What is the first law of reflection? Sir, angle of incidence equal to angle of reflection. So this is 60. This will be 60. Angle of incidence equal to angle of reflection. Okay. Now I want so I want refractive index. So Snell's law I should apply here. So let me apply Snell's law. So mu1 sine angle of incidence 60, mu2 sine refraction. This one is R, student. I don't know this one.
Sir,
So
could you check my answer?
I want this one. Okay. Yes, Mega, right answer. But you know the geometry. On a straight line, total angle should be 180. Okay, so on a straight line, total angle should be 180. Total is 180, sir. This is 60, this is 90. This should be 30 only, then total will be 180. So now mu1 sine 60 is how much? Root 3 by 2. Mu2, I don't know. Sine R is 30, 1 by 2. 2 gets cancelled. Mu2 by mu1 equal to root 3 is the right answer. Oh, Narendran. So that's an online school, huh? Don't worry. Will there be a branch in Bangalore? So, students, I don't have so much infrastructure to open a physical school. I was not able to open a physical tuition. You see, lot of marketing I should need to do. I need to go to door for advertisement, pamphlet distribution. That's not possible for me.
Yes, sir. That's why managing director, I told you, sir. Still offer open, sir.
Okay, okay. So let me see. If you are scoring very good marks, I'll just note your name. But you only after 6 to 7 years, okay? Because
Yes, sir.
you can serve many people like me, not only me. If I'm taking you right now, you'll only help me. I want you to help many people.
Thank you, sir.
Okay, students, root 3 is the right answer. Okay, yes, students. So this one. So you see, students, again I'm saying this particular thing will not be given an exam. From where to where it is going, you need to check by looking the arrows very carefully. If you are worried with the arrows, please take help of the invigilator. Again, I'm asking. So the print is not perfect. So can you help me by checking others' paper? Like that, you take help and finally decode that which from which to which the light rays travel. So here also, student, he's speaking refractive indexes, angles are given. Snell's law only will help you. Very good, Megha. Absolutely right answer. Rujuta, right answer. Wonderful students. Okay, so yes, Tanushri, help me, student. So here I want to apply Snell's law. Why? Because you see, student, he's asking refractive indexes, some angles are given. So I have only option to go for Snell's law. Medium B to medium A is asking beta. Okay, please apply Snell's law over here. Equal to symbol. Yeah, so student, what should I write? Where is Tanushri? Yeah. So here I am assuming this medium has mu of A beta. Here I am assuming this medium has mu of B. Go ahead. Mu of A.
Mu
Light is going from A to B. Mu of A into sine of.
30.
You see that. You see this is normal beta. This is normal always. Now sine of 30 I should take or 60 I should take. Incident
60.
ray is incident ray and normal. Okay, very good. Equal to now you say again
Mu of B
into sine.
45.
Okay, now I'm
Sorry.
again asking red I am taking, blue I am taking. Which angle did you take? Which 45 did you take?
Red.
Red.
Why red? Reflected ray, refracted ray, and normal. Always reference is my normal. This is normal, right? See, this one you need to take 45. Understood, Tanushri?
Yes.
Yes, Karthik says student. Yes, right answer, Karthik.
Yes, same thought.
So student, sine 60 by sine 45, you can do it. Mu of B by mu of A. Okay, I'm speeding up. Sine 60 is nothing but root 3 by 2 by 1 by root 2 equal to mu of B by mu of A. Which is nothing but mu of B by mu of A equal to root 3 into root 2 by 2. See, all your math should help you. Root 2 can be written as root 2 into root 2. This gets cancelled. Root 3 by root 2 is the right answer. Harshini, are you there, Harshini? Harshini? Is Harshini still?
Yes, sir.
You're not giving answers?
I gave the answer, sir, for this.
Okay. Tanish, mathematical mistakes a lot. You see, I have given the entire reasons. Root 3 by root 2, student. Please apply Snell's law whenever degrees and refractive index are asked and try to use simple math tricks. Okay? Yeah. So next topic is refraction through a glass slab. So it's a theoretical question. You can attempt it. Okay. So student, whenever the light is traveling through glass slab like this, you see light, incident light. This is incident light. Obviously, how should that light go? That light should go in a straight line if there is no if there is no glass slab. But will it go like this? No. Sir, outside is air, inside is glass. So rarer to denser towards normal. That is the reason, student. This has bended towards the normal. How did it bend? It bent clockwise. Okay. Now again in the glass slab, it's the same medium. Light travels in a straight line up to here. Now again here some glass slab to air, glass to air, denser to rarer, away. That's the reason my light will not go like this. It will move away from normal. That's the reason you're able to see this particular ray. Okay. Now what will be the questions on this topic is, first question. if you extend this light ray, original light incident ray, beta, see, this is incident ray, this is refracted ray, this is emergent ray. Three things are there. This is incident ray, this is refracted ray which has bended. This is also bending, but you should not call it as refracted ray. Again, the two confusion started. Both are refracted only. That's the reason this one is a refracted ray, this is an emergent ray. Okay, incident ray, refracted ray, emergent ray. Three rays are there here. So now what will the question is? If you just draw the straight extended incident ray, you will observe the final emergent ray and the incident extended incident ray. They both are parallel. So this is what the first question will be. Final emergent ray and initial incident ray, when you extend it, they both will be parallel. Why like that, sir? Why? Because here it has bended clockwise some 20 degrees I'm expecting. Air to glass. Now glass to air is just the reverse. Air to glass clockwise 20, glass to air anti-clockwise 20. That's all, student. That's the reason clockwise 20, anti-clockwise 20. Finally, it will be parallel line. Only some shift will be there. This is nothing but the displacement or lateral shift. He will ask. He will call it, student. Lateral shift will be there, but their directions both are parallel. Okay. 1 second, student. One more thing I need to explain you all. Yeah, so Harshini, what will be the angle of E and angle I? How they both will be? Will they be equal, different? Angle I and angle E, will they be equal or not equal? Yes, Harshini.
Yes, sir, I'm there.
Angle I and angle E, incident angle and emergent angle. Others, please give the answer in chat box. Vijita, okay, equal.
Sir, will be, sir, equal.
Equal only. Narendra, no. Mega equal. Okay. Yes, Mega. Why reason equal?
Sir, because they're parallel, right?
They are parallel. Okay.
So the angle formed is the same.
Okay. Okay. So she is right, student, at one cause. But if you want to take the help of geometry, you can relate like this. Yeah, Narendran, you said not equal. You see, let's take the help of geometry. You see, now both are normal lines. Both are normal lines. Now you see this angle will be equal. I and this angle will be equal. Why? Corresponding angles. But you see, this is a normal line. They both are parallel lines. So this angle also will be equal. Now you see, vertically opposite angle, they both are equal. Again, corresponding angles. Okay, and again I'll repeat it. Again, I'll repeat it for you. So little geometry, if you use, you see this is a transversal. These two are parallel lines. So if this is I, this will be I. Okay, both are corresponding angles. But if this is I, this will be I. Vertically opposite angles. But this line, both are parallel, transversal. If this is I, this will be I. Again, corresponding angles. Okay. Anyhow, there is no question of explaining this much. If you want to remember, you just remember this fellow are also equal. They both are parallel, they both are equal, and there is a lateral shift. 3 points you need to note from this. Okay. 3 points you need to note. Okay. So please explain if at all it's for 2 months. Case 1, air to glass medium. Okay. Light will bend like this. Case 2, glass to air medium. Light will bend like this. Okay. Finally, you should just say this particular statement, student. When we extend the original incident ray and the final emergent ray, they both will be parallel to each other. Okay. The angle made by emergent ray with the normal is angle of emergence. Yeah. So this one is angle of emergence. Okay. Yeah. There is a lateral displacement. Okay. There will be a question like this, student. Why does a light ray incident on a rectangular glass slab emerges parallel to itself? So if at all it is given for 2 marks, you don't write whole scenario. Okay, you please write at the air glass, you need to draw this diagram as simple as that. At this interface, we have some bending. At this interface, we have again bending in an opposite direction. That much you need to write. The bending of ray on the top face AB is equal and opposite to the bending at the bottom face. These opposite bendings make the light of ray emerges parallel to itself, and angle of incidence equal to angle of emergence.
Sir, I didn't understand what opposite to the bending means. Like,
This
what?
one, student. You see here it has bended. This was, yeah. So this is my particular emergent incident ray. It would have gone. It has bended 20 degrees clockwise. Clockwise 20 degrees. But here now the green light would have gone like this. But now the green light became blue light by moving anti-clockwise 20 degrees. So both are bending equal but opposite.
Okay, okay, sir.
Okay. Both are bending but equal but opposite. So incident and emergent are parallel reflection through glass slab. Yes, true. Okay, yeah. Now we are moving to the very important topic, which is nothing but total internal reflection. But before total internal reflection, let me give you what is critical angle. Okay, student. So let us learn what is critical angle first. Okay. Yeah. So you all have seen this statement, student. Rarer to denser, towards normal it will move. Denser to rarer, away from the normal. Okay. The first criteria, sir, the light ray should move from denser to rarer. So let me remove this case. I'm only using the light ray should move from denser to rarer because total internal reflection only happens from denser to rarer. Okay. Yeah. Look at here scenario, student. This is water. This is air. So where is the light traveling? Denser to rarer. Water is denser, rarer, rare. You see, student, there is a weak reflection. We are not at all considering whenever we are discussing refraction, but there will always be weak reflection. Okay. So here also let me cancel this case. I'm just assuming, sir, water to air. The light should have traveled like this in a straight line, but it is DRA, denser to rarer. It will move away from the normal. This is normal, so that's the reason it has bended like this for this particular angle of incidence. Now what will I do? I'll just increase this angle of incidence. Let me increase this angle of incidence more. Now it will bend further like this. Let me increase still angle of incidence. It will bend further and it will touch the surface like this. Okay. For the student who did not understand, let me take this particular scenario. You see, student, please observe at this scenario only. This scenario, light is moving from glass to air. Light is moving from glass to air, denser to rarer. Now you see I have little increased angle of incidence, angle of refraction also increased. It is moving further away, further away. I'm still increasing angle of incidence further away. So did you all watch this particular reflection angle? Let me show you. Yeah, you see, still I'm increasing, still the it is moving away from the normal. If still I increase, it will move away from the normal at one. Yeah, now you see, student, at one particular angle of incidence, how much is this angle? 0, 10, 20, 30, 40. At 40 degrees, this reflected ray has just grazed the surface. Okay, just graze the surface. You see, this has just moved the surface exactly on the surface. Okay, don't watch here. This is a weak reflection. I'm not coming to that point now. This one I'm speaking. Okay, so at one particular angle of incidence, this refracted ray is grazing the surface. That is nothing but critical angle. Okay, you see, first angle of incidence, it has bended away from the normal. That is fine. But if I still going to increase this angle, the refracted rays touching the surface, grazing the surface. That time, angle of incidence only, angle I only, I'll call it as angle C, critical angle. What is refracted ray? Please observe, my normal is here, refracted ray is here, the angle is 90 degrees here. Okay, so what is critical angle? It is that angle of incidence where the refracted ray grazes the surface. Grazes the surface means the both medium surface. And you can also say refracted rays 90 degrees to the normal at that scenario. Okay, so please understand what is critical angle. It is the same angle I only, but at which scenario the refracted ray should touch the or graze the interface at between the two mediums, like this two mediums it is touching. That scenario is known as critical angle. Okay, Karthik, understanding, student?
Sure.
Yeah. Okay, so student, but is my question of critical angle? No, I am not in critical angle. My topic is total internal reflection. Okay, so you see, I have increased my angle of incidence initially some 10. Now I increased 40 degrees. My refracted ray is touching surface. This one I am calling critical angle. Now let us see what happens if I still increase. A critical angle always be greater than refracted angle. Critical angle is always greater than refracted angle. No, student, you see refracted angle is 90 degrees. Critical angle is 40 degrees. You see this is 40, this is 90. How can it be greater?
Sir, but can you move back to the slide?
Pardon, your voice is cracking.
Can you move back to the slide?
Back to the slide, okay.
Sir, but the angle between the okay, it's 90. Okay.
Okay. Critical angle is 40 here, but the refracted angle is 90 here.
Okay, sir. Yeah.
Okay. Now what happens, sir? If I still increase the angle more than critical angle, what will happen? That is where your total internal reflection starts. Okay. You see here is up to here critical angle. Now you see if you still increase, all your light will be reflected back. This is total internal reflection. See, I still increase, student. All your light has started reflecting back like this. Okay. So that is nothing but total internal reflection. So what all is required for total internal reflection? The first requirement, light should travel from denser to rarer. You see what example I took? From the glass to the air, denser to rarer. Okay, what is the next scenario? My angle should be greater than critical angle of incidence. Yes, obviously, this is what the critical angle is, exactly touching the surface, and my total internal reflection, the angle should be more than this part, then only it will start reflecting. Okay, so these two things you just need to understand. Okay, so some questions, students. For critical angle, refracted ray should yes, Mega right, Narendran right. Student, for critical angle, what should be the refracted ray? Come on, refracted ray. You see, this is critical angle. There is a critical angle, student. This is a critical angle. What is happening to the refracted ray? Is it coming back or grazing? Don't consider this, sir. Narendran right, Harshini right, Tanushri. No, student. Refracted ray, critical angle, it is grazing the surface beta. You see, it's just going to touch. It is just going to touch. That time only I'll call critical angle. Yeah, it just touched. Soon it touched. If I still increase, it will be total internal reflection. You see, now it is total internal reflection more than critical angle. Okay, so at the critical angle, it is just grazing the surface of two medium. B is the right answer. For critical angle of refraction is. Why all are not responding? Come on, Tanish, Karthik. Respond, student. Tanish is there or not? Tanish is not there. Narendran, right answer. Rujuta, right answer. Come on, student. For critical angle, what is angle of refraction? Mega, right answer. Yeah, Tanushri, this is a critical angle, beta. It is touching the surface. What is the refractive angle? 90 degrees. That is what he has asked. Angle of refraction. Okay. So now what is total internal reflection? You see, this is normal refraction. This is critical angle. If I still increase, then this will be total internal reflection. So here theta 1 is greater than theta c. If at all for 40 degrees it is grazing, my theta 1 is more than 40, it will totally internal reflection will happen. Okay. Yes, students, a little question, some more questions, and we'll just close the session in 10 minutes. Sir. Please stay here. 10 minutes. Referring to the picture below, decide TIR is possible or not. Is total internal reflection possible or not? Narendran, right answer. Tanushri, no Tanushri. For total internal reflection. Rujuta, no Rujuta. First condition, total internal reflection, denser to rarer, beta. From the protractor, the light is going denser to rarer. First condition only fail here. You see, where is the light coming from? Light is coming from the torch. What is the direction? Please see the arrow. That is what I said. Please see the arrow. Okay, this will be happening in your exam. Okay, so now light is coming from air to glass, rarer to denser. No, first condition only denser to rarer. Understood, Tanushri?
Yes, sir.
Yeah. Yes, Rujita? Understood, beta?
Yes, sir.
Harshini, where are you, student? You're not responding. Having network issues or what?
No, sir, I sent the answer for this.
No, I didn't. I'm not at all receiving your answer. Harshini, last answer is 1920. Not
Sir, I
after the.
sent for me it is showing sent. I'll resend again.
Okay. TAR is possible. Again, check the first condition.
Sir, I sent the answer.
Again, you send student Rujita, right answer. Tanushri, again you send Harshini, wrong answer. Narendran, right answer. Tanushri, very good. Tanushri, right answer. Harshini, total internal reflection. First condition, denser to rarer, beta. Glass is denser, water is rarer. B should be the right answer. Okay, let me see who will give this answer. Can you find the critical angle of water-air interface? There is a water, beta. Water. There is an air. Oh, Rujita. Rujita, you remember this answer?
Sir, mostly in questions they give this and then they ask the speed of light. So,
Oh, okay, okay. So try to solve also. I'm happy that you remember this way. Try to solve.
yes, sir.
Okay, so critical angle is speaking. What should be your condition? From denser to rarer. That means the light should pass from water only to air. Okay. Now, will the light move like this? He is saying critical angle. This is theta c. Where should be the light stand? The light should be here. Critical angle which grazes the surface. Harshini, right answer. Okay. Now again the question is, sir, he's asking degrees. He's given interface mu. Snell's law will help you. Snell's law. Let me take the Snell's law help here. So here Snell's law, if I apply, sir, mu w into sine theta c. Here mu of air into sine r. What is r, student? 90 degrees. That's all. Finish your answer. So what will be sine theta c now? Mu air by mu w. Water. What did he give here? Mu equal 4 by 3 for water, student. He has given mu w by mu air he has given. Now you want mu air by mu w. 1 by 4 by 3. That will be 3 by 4. C is the right answer. Narendran, right, student. You see, this is a pattern, okay? So this way you need to every time analyze it, okay? So last 5 minutes, students. So let me, please hold on. I'll not do all this. Yeah. So now why the diamond chains? Yes, Narendran, why the diamond chain, student? Give me 2 reasons.
The total internal reflection.
Very good. Total intersection. Next. Anybody? Anybody who can use the next condition? Okay, so student, total internal reflection, absolutely right. You see, it's an uncut, it's a cut diamond. Whenever light travels from air to this 2.42 is what the refractive index is. Rarer to denser, total internal reflection will not happen. Light will only bend. But when light want to escape from denser to rarer, now the question comes, sir, denser to rarer, total internal reflection, first condition is accepted. If the cut is very perfect, if the cut of is very perfect, obviously the light will reflect back. If the cut is very perfect here, again denser to rarer, light will reflect back. Like that, the light is trapped in the diamond and also 2.42 students, the speed of light will be very less. So this total internal reflection due to the reduction of light speed, and dispersion is the next way. Dispersion, which we have learned in chapter number 2. White light pass, rainbow color splits. Yes, high refractive index, right answer, Rujita. Dispersion also, okay, when white light is passed, so you see something like rainbow effect is born. Okay, these are the few reasons this particular diamond change, student. Okay, yeah, so the last case is your all our world is connected with the optical fibers. Optical fibers are nothing but glass. So in the glass, what will travel? Will electrical signal travel? No, electrical signal travels only in the copper wire, okay, or through the air. But our all the world is connected with the optical fibers through the sea, through the tunnels, through the land. So what should travel in that optical fibers? The light will travel. How can a light travel in the optical fiber? Again, the total internal reflection. The light is adjusted so that it will reflect like this, and I'm in Hyderabad, you are in Bangalore. So that's the reason the speed of light is 3 lakh kilometer per second. Hyderabad and Bangalore is hardly radially. I think it's 500, not even 500. I guess radially 300. I guess. Okay. So that's the reason within a fraction of second, my voice, which is converted to light, is traveling through optical fiber, is reached to the Bangalore within fraction of second. That's the reason there is no delay now. Okay. So in optical fiber, which concept we use? Total internal reflection. Okay. The total internal reflection is more in which way? Cut diamond. That's the reason cut diamond is costly also. It shines a lot. To buy a diamond, 3 C's you should check. 3 C's. Cost, cut, color. 3 C's you should check. So cut is also one of the important why the diamond change. Okay. With that, I have completed all the basics. Next Sunday, I'll go for the class on plane mirror, convex mirror, concave mirror, lens also I'll complete. Please be available for the class if you are not confident, if you are doing it for first time, or else please be available for the sample paper discussion. Okay, students? That's all from my side.
Thank you, sir.
Thank
Yes.
you, sir.
Thank you. Thank you.
Thank you so much.
Thank you. Bye bye.